In this video, I will talk about impedance, impedance triangle, power triangle, real power, reactive power, apparent power, and the power factor of a series RC circuit. See, I have a resistor R which is connected in series with a capacitor whose capacitance is C. And we are applying an alternating voltage V equal to Vm sin omega t in this circuit. See, as this is a total series circuit, you will see there will be a current flow I which will be same all over the circuit. And if in this circuit we apply KVL in clockwise direction in phasor form, we will get applied voltage phasor V equal to sum of resistance voltage drop phasor VR plus capacitance voltage drop phasor VC. V vector will be equal to the sum of VR vector and VC vector. Now let me talk about impedance. The word impede means oppose, prevent, restrain. So in a circuit, impedance will oppose the or restrain the current flow, or it will prevent the current flowing in a circuit. As a result, you will see if we increase the value of impedance, our current flow will decrease because we will provide more opposition to current flow, therefore the amount of current in that circuit will decrease. Now let me discuss the concept of impedance. When does the word impedance come into existence? If in a circuit we have inductance L or capacitance C or both in addition to resistor R, the total opposition or the combined opposition due to the resistance or inductance or capacitance or their combination to current flow will be the impedance of that circuit. We denote the impedance with capital Z. See, impedance is the total opposition offered to current flow, therefore impedance Z will provide opposition to the current flow. If it increases, this will decrease by an inductor or capacitor or both in addition to the resistor is called impedance. Okay, we can define the impedance of a circuit by taking the ratio of phasor voltage V and phasor current I. See, in the second definition, the impedance of a circuit is also defined as the ratio of phasor voltage V and the phasor current I, and the unit of impedance will be ohm. Okay, now I will show you how do we calculate the impedance of this RC series circuit. We will calculate the impedance of this RC series circuit from the voltage triangle which I have shown you in my previous video. Now see, we define the impedance of a circuit by taking the ratio of phasor voltage V and the phasor current I. Impedance Z is the ratio of phasor voltage V and the phasor current I, and this is the voltage triangle of the RC series circuit. And in the positive x-axis, or if I write it in terms of real and imaginary axis, you will see I will take the reference phasor in the real axis. Okay, now see, if I decompose the current phasor I, here I will get I current phasor equal to real part plus J0, because this current phasor is going in the real axis, so it will not have any imaginary part. Now see, the voltage drop across this resistor VR is also going in the same direction, so it will also have no imaginary part because it is going in the direction of real axis. It will be phasor current I into R plus J0. Now look at this VC. VC is going in the negative J axis, therefore it will not have any real part, rather it will have negative imaginary component minus j into phasor current I x c. Now see, in the circuit if we apply KVL in phasor domain, we get V vector equal to VR plus VC. V vector is the sum of VR and VC, and here you will see VR is given by IR J0. So if I put it here, I will get IR plus J0 plus 0 minus J into I phasor X C. So here I will get I phasor into R minus J X C. This is equal to our voltage phasor V. Now see, I have the voltage phasor and current phasor. If I take the ratio of voltage phasor V and current phasor I will get our impedance, and that will be R minus J X C. So the impedance of the RC series circuit will be R minus J X C. Now see, what will be the magnitude of this impedance? It will be root over R square plus XC square. And what will be the phase angle? Phase angle phi will be equal to tan inverse minus XC divided by R. So the impedance of a series RC circuit is given by Z equal to R minus JXC, and the magnitude of the impedance Z will be equal to modulus of Z will be equal to R square plus XC square. Now I will show you the impedance triangle of series RC circuit. What is impedance triangle? Impedance triangle is a graphical representation of resistance R, reactance X and the impedance Z in a right triangle. That means our impedance triangle will be a right triangle in which three sides of that right triangle, one will indicate the resistance, one will indicate the reactance, and another will indicate the impedance Z. Let's say I have this right triangle. This is the horizontal axis, this is the vertical axis, and this is the hypotenuse. Now see, in a right angle triangle, I will represent the impedance in the hypotenuse of the right triangle. I will represent the resistance R in the horizontal axis. I will represent the reactance. Here the reactance will be XC in the vertical axis. Usually we draw the impedance triangle from the voltage triangle of a circuit. See, this is the voltage triangle of the RC circuit, which I have shown you in my previous video. Now see, in this direction VR equal to IR, in this direction VC equal to IXC, and in this direction V equal to IZ. This is a right angle, and between the voltage and the reference phasor I, we have an angular displacement of phi, and I leads V by angle of phi. Now see, from this voltage triangle I can draw the impedance triangle. See, if we have a resistor R, if the voltage across that resistance is VR and if the current through that resistance is I, if I take the ratio of voltage across that resistor through the current that resistor, we will get the resistance. Simple Ohm's law. If we have a capacitor C, if the voltage across that capacitor is VC and if the charging current is I, capacitive reactance is defined as the ratio of phasor voltage of that voltage VC to the current, phasor current or the charging phasor current through that capacitor. So XC will be VC by I. If in a circuit the applied voltage is V and the total current I, if I take the ratio of applied voltage by current, I will get the impedance Z. Z is the ratio of phasor voltage to phasor current, total applied voltage to total current in the circuit. See here, in VR equal to IR, this I common, this I is common here, and this I is common here. In all the terms I have I. Now see, if I divide each side of voltage triangle with current I will get impedance triangle. See, if I divide this side with I will get VR by I. This I will get cancelled and I will divide this with I will get VR by I equal to R. See, VR by I equal to R. So this side will represent resistance R. Here if I take the ratio of VC by I will get XC. VC by I equal to XC in this direction. And see here, if I take the ratio of V by I will get the impedance, phasor voltage by phasor current. V by I equal to impedance. So see, this is the angular displacement between the resistance and impedance, which is equal to phi. Now see, in the horizontal axis we are representing the resistance, in the vertical axis we are representing the capacitive reactance, and in the hypotenuse, see, this angle will be 90 degree. So this will be the hypotenuse. In the hypotenuse we are representing the impedance. Therefore this will be a right triangle, and in which we are representing the resistance, reactance and the impedance. So this will be our impedance triangle. What is the usefulness of this impedance triangle? We can determine 4 pieces of information from this impedance triangle. First one is, we can find the impedance by using Pythagorean theorem. This is the hypotenuse. So hypotenuse square equal to base square plus height square, z square equal to r square plus xc square. So you will see, we will get impedance of the circuit will be root over r square plus xc square. Second one is that power factor cos phi, which is the ratio of resistance and impedance of the circuit. Now see, we can deduce the impedance, therefore I can easily calculate the power factor, r square plus xc square. Angular displacement between the resistance and impedance, or angular displacement between the voltage and current, which will be equal to, let's say, 10 phi. 10 phi is the ratio of height to base. Here height is xc and base is r, and we can determine whether the current leads or lags the applied voltage. See here, if we take the current phasor in this direction, this will be our phasor voltage. This indicates that our phasor current leads the V by phi. So in a capacitive circuit, current I leads V by an angle phi, and in case of a pure capacitor, V lags or I leads by 90 degree. Now let me talk about the power triangle of series RC circuit. Power triangle. What is power triangle? The graphical relation of real power, reactive power and apparent power can be illustrated using a right triangle called power triangle. See, we have 3 power components: real power or active power, reactive power and apparent power. We can illustrate the relation between these 3 power using a right triangle. That right triangle is known as power triangle. Let's say if I have this right triangle here, this will be its horizontal axis, this will be its vertical axis, and this axis will be known as hypotenuse of the right triangle. Now see, here you will see we will represent the real power in the direction of horizontal axis. We will represent the reactive power in the direction of vertical axis, and we will represent the apparent power or total power of the circuit in the direction of hypotenuse. So this will be our impedance triangle if I can show the relationship between the three power component using this right triangle. See, this is the voltage triangle of the series RC circuit. In this direction I am taking VR equal to IR, in this direction VC equal to IXC, and in this direction V equal to IZ. Now see, if I multiply each side of the voltage triangle, I will get the power triangle of the series RC circuit. See, in this direction we have VR. If I multiply this with I will get I into VR, or VRI, or I square R. If I multiply this with I will get IBC, or I square XC, or in this direction I will get I into V, or I square Z. Therefore you will see all the components will be power components. So in this direction we will get VRI equal to I square R. In this direction we will get IVC, or I square XC, and in this direction we will get VI, or I square Z. Now see, this will be a right triangle. In this direction I am getting VR into I, or I square R. This is known as real or true power. In this direction I will get reactive power, because capacitor is a reactive component, and in this direction I am getting apparent or true power. And see, three sides of the right triangle represents three power component. Therefore this right triangle will be our power triangle. Okay, now let me talk about real power, reactive power, and apparent power. After that I will talk about power factor. Okay, let me talk about apparent power or total power. Sorry, this is not true power, this will be total power. What is the apparent power or total power in a circuit? Apparent power or total power in a circuit is the power that is supplied by the source in the circuit. And we calculate the apparent power or total power in a circuit by multiplying the RMS value of the voltage and RMS value of current I. This is also known as volt ampere, and the unit of the total power will be VA. Okay, after that real power or true power or active power. What is real power? See, in a RC series circuit we will have resistor. The power absorbed by the resistor, that power will be known as real power or true power, and in a circuit the work is done by the real power. Once the power is absorbed by the resistor, we cannot recover that power. See, this is our VI. It will have two components. One will be horizontal component, another will be vertical component. This direction we will get VI cosine phi. Therefore you will see we will calculate real power of any alternating circuit by taking the RMS value of voltage into RMS value of current into cosine of the phase angle between voltage and current, or see here we have VR into I. VR is the voltage drop across resistor, and this VR is RMS value, this I is also RMS value of voltage and current. The real power has a unit of watt. What is reactive power? See, in the RC series circuit we will have the capacitor, see, which is a reactive component, and we know that capacitor stores electrical energy in the form of electrostatic energy or as a charge. Now see, what is reactive power? Reactive power is the power stored in the reactive component of the circuit, or the inductor or capacitor in a circuit. Here we have the reactive component capacitor. Therefore I can say in the RC series circuit the power stored in the capacitor will be the reactive power. Now see, in a reactive component it will draw power from the source in one half cycle or positive half cycle, and it will return that power to the source in the next half cycle. As a result, over a full cycle the power in that reactive element will be equal to 0. Therefore with the reactive power we cannot do any meaningful work. Now how do we calculate the reactive power in any circuit? Reactive power is expressed with Q, and we calculate the Q by multiplying the RMS value of voltage, RMS value of current, and the sine component of the phase angle between voltage and current. See, VI, see, this will indicate the VI sine component of the apparent power VI, or here VC I or I square XC. This VCI or I square XC will be RMS quantity. The unit of this reactive power will be var. Now let me talk about the power factor of this RC series circuit. Power factor: if phi is the angle between the applied voltage V and the alternating current I, we will get power factor equal to cosine phi. Or if I know the value of resistor and impedance equal to Z, I can easily calculate cosine phi. It will be R divided by root over R square plus XC square. Or if I know the value of real power and the apparent power, I can easily calculate power factor. Here real power will be given by VI cosine phi, and the reactive power and the apparent power is given by VI. Okay. In case of a capacitive circuit, our current I always leads V by some angle phi, as I will always be ahead of the voltage. Therefore in case of capacitor, power factor will always be leading. Okay, that's it. Thank you.